Okay. What questions do you have that you need answered from the final exam review? Can y'all hear me? Hello? All right, guys. What you got? Nothing. Okay, I got Hillary, got Dext, got Doster has arrived. There's chat box down there. I just need to know. It's 3:30. So y'all tell me what you need help on. Y'all got anything that you need help on, or you just kind of okay? Number 69. So okay. All right. Let's see. All right. Angela's saying she got a different answer than what they got on the answer key. That's okay. Let's look at it. So, all right. So, right to parabola standing at negative 2x plus 8x plus or minus 10. So, let's go h equals negative b over 2a. So, that's negative 8 over 2 times negative 2, which is negative 8 over negative 4, which is 2. So I got the h value to be 2. You can substitute in, here's my calculator, 2 back into the equation, and that should give us this. And change color. So that's 2 squared is 4. 4 times 2 is negative 8. Plus 16 minus 10. So that's 8 minus 10, which is 2. Now, this is the A. So we're putting it in that form, right? So y equals negative 2 x minus 2 squared plus 2. Let's see what they got on the final exam answer for that. No, there's a problem with that. I got this. Did you? I got okay. Then there's an error on that, so that's something that they'll just kind of be aware of. So there is an error on number 69. It should be this. Okay, and 93. Let's look at 93 real quick. Is it an error on it, or are they just not? Okay. Don't know, can't follow her. Okay. Well, let's work it, and then we'll just compare what she's got. That way, I won't be led astray by anything that's going there. All right. So first things first. Let's do -6. So we have 2 log of 8n plus 4 equals 4, right? I can turn around and divide both sides by 2. That to give me the log of 8n plus 4 equals 2, right? Now, we can, this is a log base 10 since it's a common log, so we can rewrite it in exponential, which would give me 10 squared equal to 8n plus 4. So that's 100 equals 8n plus 4 minus 4. 96 equals 8n. Ladies and gentlemen, n should equal 12, right? My math is right. Yeah. So I got 12. So let's see what, do you agree with what I got, Angela? We'll go see what she got. Okay, thanks. I see what, okay. All right. The thing about this is, yeah, we know that 2's a power here, but you can just go ahead, it's multiplied times it, so we can just divide it, and that gave us this. And then to solve a log, we have to convert it, use 2 as a power. You could put it back up there and everything, but you would, it would just be a lot harder. Yeah. So, and if you plug negative 11 in, Angela said when she done it, she got 2 answers, which would be a quadratic. That's absolutely correct. She got 12 and negative 11. You remember when I said you'll have extraneous roots possibly on a log? If you plug negative 11 back in, 8 times negative 11 is negative 88. Plus 4 would be negative 44. You can't take the log of negative 84. So that would be negative 11 would be a extraneous root. You solve for it, but it doesn't work because you can't take the log of a negative number. So even though you squared the 8n plus 4 and solved the quadratic, it gave you an extraneous root. So, all right, anything else, guys? Did everybody look at your emails and get the list of things that I sent as far as which problems to make sure that you knew how to do? Hold up, Angela. All right. Dexter said yes. That's one I got. All right. I didn't count how many problems that was on that particular thing, but I went through and selected ones that you need to make sure you understand the content on, because you may see that content again. Okay. So I'm gonna hold off on Angela. I think Angela said 97. Anybody got one in particular? We'll try to share the help session a little bit, kind of space around different people, allow them to answer different questions. But if I don't have any takers, then I'll go to the next person that wants something worked. So before I do 97, let me ask that. Or y'all, is there one in particular you want to see, or is there something that you want to be worked out? No takers? All right. I think Angela said 97, so let me see what 97 is. Yeah, that's a real good one. Okay, let's look at this. An isotope of lead 201 ppb has a half-life of 9.1 hours, meaning it takes 9.1 hours to reach half of its mass. How many hours ago was there 35% more of the substance? So let's see something real quick. Okay. How many hours ago was there 35% more of the substance? So if it's half-life, let's think about that. Half-life means that there's well, let me get off this. Let me go and erase that. Now this is how I'm looking at it, and then I'll check the answer. But half-life means there's 50% there. So how many hours ago was the 35% more? Well, let's see. If you take 50%, which is 0.5, and say, okay, how many hours ago was there 35% more of the substance? So that amount plus 35%. So if you took, now this is the way I'm doing it, times, what, I just put the times there, 1.35. Does everybody understand where I got the 1.35? One is 100% of the half, and then 35% growth more of the half. So that should give me 0.675. So we want to know, when was it 0.675? So I'll write this out. The base is 1/2 raised to the time, right? Ending, beginning. So basically what you're saying is your ending amount is that percent, right? Ending divided by beginning should be 0.675, so 1/2 raised to the t. So we will take we can take natural log, or we can take log. It doesn't really matter to me, but we'll take log of both sides, and then we'll bring the t out in front. So that's t log of 1/2 equals the log of 0.675, and then we will divide both sides by log of 1/2, which will give me t. Now let's kind of look at this. 0.675 divided by log of half. I got 0.567, so alright, so that was 97. Now let's go check and see what they got. I said that. Did anybody else get 0.567 before I checked that? Well, 97. Huh. Why did they do that? No, it's a different problem. We know the half-life for decay rate. Yeah, we got to find the decay rate. equals that. Yeah, I didn't read it at that. I took it as being 35% more of a half. So let's kind of look and see what she's done here. Because the way that I went was a little bit different than what this was. So let's see if we know that the half-life, we can find the decay rate using K times 9.1. Okay. So let me copy this, and then I can explain it. Look on your formula sheet. I think y'all have that. And then I'll explain what. Yeah, but they're also using, okay, yeah. I don't really 100% agree with this problem, but we'll look at it. There's a lot that's to be assumed in this problem. So look on your formula sheet and see if there's a half-life decay rate formula on there. Probably on the back, maybe, or the bottom. Yeah, for both. What do you mean for both? Oh, there's a define the decay rate, and then there's a equation as well. Both formulas. What do you mean? All right, let me check something because. All right. So they gave, let's just make sure, they gave this formula here that I just highlighted. Yes or no? Okay. And you're saying the other formula was it this? I hate to say that, but they're putting beginning, ending, and then some rate. Okay. All right. So, okay. Where did all this come from? So what you have to understand is, and we'll go back and look, since my interpretation of the problem was totally different from that, there's 35% more of the half of it. So how many hours ago was that 35? That's a really bad question, because it leaves you to believe, okay, is it 35% more of half of it, or 35% more at the beginning? So according to this problem, it's 35% more at the beginning. So let's kind of talk about this equation right here. How did they get the rate? So negative natural log of 2 over t is a formula that you can derive to get to the rate, but they're going to give it to you. So it's negative natural log of 2. Why is it 2? Because of half-life. And then time. How much time does it take to get that half-life? And they went out to 1, 2, 3, 4, 5, 6. No, 5 decimals. Why did they go out to 5? For more accuracy, less of a chance to introduce error. So you'd have to solve for this first, okay? That's your rate, and that's your R, right? So it's basically ending amount equals beginning amount times e raised to the RT, right? So that's negative RT. So A equals P. And this R is what you're finding right here, okay? They've done the same thing that we done before, that I did on the previous problem, beginning, finding it. I took 50%, so I'm saying, okay, the ratio of that was 0.675. So But you see how I took the log of both sides on the work that I done based off my interpretation of how much we really began with. We're going to get to the same thing, except for they're putting 1.35, meaning 35% more than what they had to begin with. And then 1 divided by that, that's the same as what we were doing before. But they took the natural log of it. The reason they took the natural log of it is to make this e cancel, right? And that's what happened here. So natural log of 1.35 divided by the rate will equals time. So what do you get for time? Well, let's see. They got time to be approximately 3.94 hours. Okay. So there. That is a really good problem. You'll probably see that one again. I don't like the way it's worded, so if it's worded like that, I'll probably kill it just because it's a poor worded question. There's too much ambiguity there. So, okay. All right, any questions on that? They are assuming that you have to use this continuous decay. Okay. All right. So growth and decay functions is the same as P. Yeah. The difference is this. If it was a growth, it'd be a positive R, meaning your rate would be positive. But if it's a decay, it'd be a negative R, right? It goes back to the theory of this. 2 to the x is growth. 2 to the negative x is decay, right? We talked about this when we was talking about exponentials, but that's really the same as this, right? 2 to the negative x is the same as 1/2 to the x. So that's what they're doing there. They're taking there. They're taking. Oh shoot! There. That negative is saying it's a decay. The positive saying that is a growth. If your base is above 1, they would notate it as such. But if your base is between 0 and 1, then you know it's a decay. All right. So that's 2 alternate forms of how they can write that. All right. Anything else? Let's see who's here. We got Al, got Angela, got Dex, Francisco, Hillary. All right, guys. So there's 6 of you. There should be a chat box down there. You could type in what question you want to see, and we'll go from there. Okay. So, any takers? While y'all looking at that, and I probably should have said this before, I don't sit and just work problems for a final exam review. I work the problems that you need me to work or explain, because if I start working problems that then you're going to come across things that are going to be obstacles that you haven't looked at or need answered, and I won't be there. Okay, so take advantage of this time if you will. All right, so growth indicates. All right, 102. So let's look at 102. Yeah, I'm recording it, Dex. So, all right, 102 is one that we looked at. I think it's been in the homework with 2. So let's kind of look at this. And 104 is coming up next, so let me just go ahead and grab that while I'm here. All right. The streaming of this will be, I'll put it up on the website after it'll take probably about 15 minutes or more to process it, and then or to convert it, and then it'll take probably about 10 minutes. So probably 30 minutes after we get done, you'll be able to see it online. So let's go look at 103 or 102. If an investor invests $23,000 into 2 bonds, one pays 4% simple interest. So that's simple interest is basically telling you this, guys. Dang it. IPRT, right? So P is the principal, I is the interest he makes, R is the rate as a decimal, and T is the time in years. So he puts it into 2 bonds, one that pays 4 and then one that pays 2, right? So he earned $710. How much was invested in each account? So we got account A, and then we've got account B, and then we've got the interest, right? So that's kind of how I'm going to set this up. So account A, well, the time is the same, right? So we ain't got to worry about T, so it would just be P times R. So let's just kind of look at it. We'll say that this is 4%. And then we'll look over here at this one and call it, what, 2%? Well, I want to do that. Make that a little bit bigger there. Okay. So, and that's equal to $710. All right, guys. So we need how much did he put in account A and how much did he put in account B? Well, he invested $23,000, right? So if we say he put $23,000 in account A, well, then he would have had to put 23,000 minus X, right? And I put the plus here because account A plus account B has to equal $710, right? So 0.04 times 23,000 gives me 920. Plus the amounts here, guys, is if I make one 23,000, I make the other one 23. Sorry, my bad. I just made a mistake. Yep, no, I just called it 2. Sorry. Some of y'all are probably going, what are you doing? There, X and then 23,000 minus X, right? For the other one, so that would be 0.04X, and then this would be 23,000 times 0.02, which gives me 460 minus 0.02X, 710. So what I got there is 0.02X plus 460 equals 710, and then minus 460. That's going to give us 0.02X equal to 710 minus 460. It's 250. And of course, guys, we'll divide both sides by 0.02. So X will be equal to 12,500. So he put 12,500 in the one at 4%. And then if we want to know how much you put in account B, it'd be 23,000 minus 12,500, which gives me 10,500. I think we've had 2 homework problems like this in 2 different sections, linear, and then I think it came back up on maybe applications of linear. So it should be 2 sets of homework that dealt with a problem like that. So make sure that you can do that. Okay. I think Al asked this one. So you good, Al, on this? Okay. Biggest thing is you got to know it's I equals P times R times T, and they're giving you 2 scenarios, so account A, account B equals that. And time is the same, so we got to take into account for that. So, okay. All right, Dex, let's look at yours. So the perimeter of a triangle is 30 inches. So we know perimeter equals 30, right? The longest side is 2 less than 3 times the shortest side. Oh, snap. Okay. And then we'll say here, we got longest, other side, and shortest, right? So, all right, remember that this is a triangle, correct? That looks like a beaker. It's a triangle. So the longest side is 2 less than 3 times the shortest side. Well, we don't even know what the shortest side is, so we're going to say it's x, right? And once we notate that, it's going to give us the ability to write relationships back to the shortest side. So if it's 2 less than 3 times, then that's 3x minus 2. And then the other side is 2 more than twice that. So that'd be 2x plus 2. And then all we have to do is basically say, okay, x plus 2x plus 2 plus 3x minus 2 is equal to 30. And we just solve for x, right? Find the length of each side. So x, and 3x, and 2x is 3x, 3x is 6x. And then that's equal to 30 because the 2's cancel, right? So divide by 6, so x equals 5. So we have the shortest being 5, the other side being 12, and then this one is what? 13, because 5 times 3 is 15 minus 2, so 5, 12, 13. If you know your triangles, that's a Pythagorean triple, okay, which is pretty cool. Yeah, I think, well, if you add those up, it also gives you 30, so we know it's right. So, any other questions on this, Dex? That help you? Okay, these relationships here, you got to make sure you can do that. And if you will pay attention, it says 2 less. If less than is in the beginning, that number goes behind it, right? And more than, if it's in the beginning, it goes behind it as well. You remember less than, greater than. If they're in the beginning, that number goes in the end. If it's in less than and greater than is in the end, then that goes back in. That number goes back into the beginning, right? So I think that's the rules for that. Okay. All right. So that took care of 104. All right. Question 98. And then Angela, what was the question that you were wanting to see? Oh. You're done with the review that all the questions that I marked plus any other ones on there? You got all your questions answered? Is that what you, yeah, okay. All right, so you just gonna hang out and listen. Okay. All right. So D equals R times T. And will you have one like this? Yeah, probably so. So let's go look at it. Okay. Steve leaves school by moped. Wow. Let me shrink that up a little bit. For vacation. 45 minutes later, his roommate Frank notices that Steve forgot his camera. So Frank decides to try to catch up with Steve by his car, or by car. If Steve's average speed is 25 and Frank's 45, how long does it take Frank to catch Steve? Now, there's a rule of thumb on this. So just pay attention, because different people set this up different ways, so we'll make sure that we come out with the right way. Distance equals rate times time. That's the main formula you got to make sure you understand, right? So let's talk about Steve, and then we'll come over here and we'll talk about Frank, and then we'll set an equation up, okay? Steve's distance, rate, and time, and then Frank's distance, rate, and time. Well, they're driving the same distance, right? So their distances are the same, because if Steve leaves and then Frank notices that Steve left something and they're trying to catch up, well, if Steve's 10 miles down the road from the house he left from, and Frank catches up with him 10 miles down, so their distances are the same. Now, if their distances are the same, then that means I'm going to take basically R times T equals R times T, because their distances, guys, are the same, okay? So let's look at what we got to decipher for Steve and Frank. We know that Steve is on that moped just getting it down the road, and he's going at 25, but Frank is at 45. So if we say that Steve starts at time T, right? Now, Steve's driving at a slower rate, right? And Frank's driving at 45. So it's going to take Frank less time to catch Steve. Do everybody in agreement with that? I know from in class you could probably say yay or nay. So what you got to understand is I'm going to write Frank's time with respect to Steve's, right? If it takes Steve 30 minutes, it's going to take Frank a little bit less, right? 30 minus some amount. So T minus 45, okay? Because it was in 45 minutes. But we got to make sure we catch something here, because what I just wrote will make it come out wrong. And if you got to pay particular attention to units, okay? Because this is miles per, oh, thank you, Dex. It says 40, not 45. Thank you. It says 40. Thank you. So T minus 40 minutes, right? But the T's not in minutes. Well, it is, but guys, look at its rates. Its rates in miles per hour, right? So how long of an hour is 40 minutes? So you would do 40 divided by 60. That's right. 2/3 an hour, right? So T minus 2/3, right? Boy, if I could write on this thing, it'd be great. 2/3. Does everybody see how we got and why we had to convert it we can't use the T minus 40, unless we convert miles per hour to miles per minute, we could, which may make the math a little bit easier too. Can you repeat why? All right, so time is in minutes, right? But look at your rate. It's in miles per hour. So we want to know basically how long is it going to take, right? And we got to make sure units cancel out. If it's in miles per hour, then times has to be in hours, so that we know what's going on. So we're going to have 25 T equals 45 T minus 2/3. Okay. And then we'll go from there. I'm going to take this and move it, move this down to there, right? Okay. Now we can work this. So we'll distribute. So that's 45T equals 25T minus, well, my calculator times negative 2/3. If I can type this in correctly. I got 30, right? 2/3 of 45 is 30. So what we're going to do is we'll take it and we'll minus 45T. So that would be 25 minus 45 should be negative 20T, right? Equals negative 30. So what does that give me? 1.5, right? 3 divided by 2 is 1.5. So it takes, the overall time is 1.5 hours, right? Because that's Steve's time. That's T, right? So that's T, and this is T. So it's Steve's time. Now, Frank, well, to make life a little bit easier, guys, we can convert the hours back into minutes and subtract 40, right? So it'd be a little bit easier to look at. So well, here we go. So that's what that is. 1.5 hours is what? 90 minutes minus 40, right? So 90 minus 40 is 50 minutes. Now, so he's been driving for 90 minutes while Frank has drove only 50. How long does it take Frank to catch Steve? It takes him 50 minutes, or 50 divided by 60, which would be 0.833, which would be 5/6 of an hour, or 0.83 of an hour, but 50 minutes is probably what it's going to be. So let's go see how we did. That's 98. Hey, look at that. She done plus. Yeah. There you go. We got the same thing. Right. But we wrote, okay, we said Steve was T, and we wrote Frank as T minus 2/3, right? And we got T to be 1.5 hours. Let me put that in hours so that people can see that. That's in hours, which is really 90 minutes. So 90 minutes minus 40, it gives us 50 minutes. That's how long Frank has been driving. So if we go back and look here, we go there, you can see, even though they set it up in a table, We still got Frank at 50 minutes, right? So, all right. Any questions? I always do. If they leave later, that person, I always, they put it, Steve's time is T plus 2/3, which is 40 minutes, right? Additional time that he's been driving, and they put Frank at T. So that's why they put T plus 2/3. Guys, I wrote mine in terms T being Steve, right? Steve left first, so I put my times in T with Steve. So Frank had to be less than my total time, right? So that's why it's T minus. And we converted the 40 minutes over into an hour, which is 2/3 of an hour. So that's why it's T minus 2/3. So that's the two scenarios of how to work that problem. But my brain just goes with who's been there the longest or who's been driving the longest. That's the T. And then T minus for the person that has been traveling less time, and by how much less. So, all right. Hopefully that made a lot of sense. But you could probably see one like that. Again, hint. All right. Anything else, guys? Let's see who's on here. Who's being quiet? Hillary's being quiet. Let's see. Dex has been asking. Angela says Al's asked one. Al, do we have access to the answers? Yeah, you have access to the answers. I didn't give it to you in class, but yeah, you sure do. The website that I sent you, let me go here. Should be https math 111111 tp.weebly.com. This has everything, so this is where you're going to go, and this is in a email. If you look at the very bottom, it says final exam review with solutions. If you hit that, then it takes you to the solutions, and then you can compare. It also has, let's open it up, a new window, the final exam review, all the notes, the videos. That's where there we go. And this actually has the last night that we met, October 3rd. So that's all on there. You can see everyone that we started recording back in August the 27th. So just kind of be aware of that. And that's where I'll put the this help session. I'll throw this final exam review help session will be on this site. So just kind of make sure that you are aware of that. Okay. All right. Okay. Whose question was that? I think this was Dex's question, right? Dex, you okay with that, bub? Does it make sense how I wrote mine T minus and the solution guide wrote it T plus? It all depends on who you write it in terms of, Frank or Steve. And I normally make my T the one who's been there the longest. So that way it's always T minus something. And note that my negatives took care of themselves because we can't go back in time and do time travel. So next up, it's your Math 1111 final exam review request line. Taking the next caller. Any takers out there? Has everybody finished your test? I haven't checked today. And while I've got you on here, sent out an email about the homework being reopened. Now that's what that's going to do is if you've got it completed, then it'll factor in, but it's not going to truly factor it in till 6 o'clock on Monday. I have the homeworks all open till 6 o'clock on Monday for you to be able to go back and work any kind of problems you want to use it to prepare for your final exam. So that's why that, and that's probably what you've seen in your adjustment of your grade. Okay, so Dex is 88. So let's go here. Okay, use it without a calculator. Well, okay, we're still going to use a calculator. We're not going to do it without it. I mean, but we will do some things that's going to make it a little bit easier for us. Okay, so all right, so if we're going to evaluate this without using a calculator, then we're not. But the first thing I would do is I would turn around. You can type it in just like it is. If you have a calculator that lets you put a base and then the of, and then you can do -3 times log base 3 of 3. Now, with that being said, if you don't have one of those calculators, then let's talk about this. We're going to move this 3 back up here, and because we know it is a subtraction, then we know it's a division, correct? So let's talk about this. It's log, and these are all log 3. Now that's 1/9 over 3 cubed would be 27, right? So you can evaluate this as being, go back here. It would be the log, if we use change base formula, it would be the log of 1/9 over, well, let me back up. There. It'd be the log of 1/9 over 27 over the log of 3, right? Change of base. But let me see something real quick. If I make that a log, and you can do that, but this should be, let's see, 1/9 divided by 27 would actually be 1/9 times 1 over 27. We'll see if my thinking is right. That's 1 over 243. So let me nerd out for a second. So I've got really log the base of 3 of 1 over 240. Log base 3, 1 over 243. Everybody understand how I got 243? 1 over that equals the x. And if you solve it without it, then it's really 3x, right? Equal to 1 over 243. Can I raise 3 raised to the 5th power? Yeah. So really what this becomes is 3x equals 1 over 3 to the 5th power, right? Now you should note that if I need to move things, then it'll allow me to do this, and it's the negative power rule is basically what I'm going to use to do this. If I move it from the bottom to the top, then the exponent has to change signs. That's really what the negative power rule is doing. That's how we are able to get it from a negative exponent back to a positive. Well, guys, if you need to take this and put it back up as a base raised to a negative power, then you can reverse that. And this would give us x equals -5. But if you do it on the calculator, I mean, you're still going to get the same thing. If I took log of, let's do big parentheses, 1 divided by 9 divided by 27, close parentheses, divided by log of 3. Guys, I still get -5. Change base still works the same. So all this stuff right in here that I've done, here, this, is just manipulating it with the powers. I convert it back to one single log like that, and then I would do the change of base. And guys, you'd still get, when you do change of base, you'd still get -5, so you're good. All right, would you have to do that? Yeah, probably so. Yeah, it's pretty good possibility you're going to have one like that. Now, if it says evaluate without the calculator, no, do it with the calculator. I mean, this is a time final. You got 2 hours, right? Work smarter, not harder. You've shown me what you can do on your test. So this is time to show up and show out, right? So.
Palmer, can you hear me?
Yeah. Who's this?
Sorry. Angela.
Yeah.
The way she's got it on the thing is she's saying that log 3 to the argument 1/9 is just -2.
Mm-hmm.
And you can do that in it. So that following that logic, if it was like log base 5 of the argument 1/25, would it be like still be -2 because you always do that?
No. Let me show you what she's doing. I'm going to mute you real quick. Let me also do this because I don't want that. Yeah, I don't want. Okay, share my screen. I don't want that. Share my screen. Come on. I want y'all to see me. Y'all see me enough. Okay. So, dadgummit. Is it? You said it was 80 something, right? Yeah. So I'm gonna show you what she's done, and you can work this about 5, 6 ways, really. If I can get to the problem. There. Shoot. 88. Okay. I'm at 89, so I need to go a little bit more. Yeah. Okay. So what she's done is this. Log base 3 of 3. If the base in the of here is the same, then that becomes really 1. That's where this 1 came from. But those are properties, right? And you've got to see those properties. You've got to know how to use those properties. And let's just be honest. We really didn't get into really extensively using those properties and everything. So that's how they got the 1, right? As long as it's like this, log base b of b is equal to 1, right? Now this is -3 times that, and if you look on the back of your sheet, you see the that property. So that's where the 1 came from. This is really, guys, this. And if you took that -2 out front and moved it out here, right? Took this and moved it out there, then this also becomes, guess what? 1, right? Which would be -2 times that. So that's how they got -5 a little bit quicker. It just depends on what property you use. You can get to it quick, or you can use the combining them. It really is just what path do you want to go, and what does your brain see? What does your eyes tell your brain that you're looking at, and what are you picking up on? I mean, the really cool thing about math is no matter what path you go down, as long as what you're doing is right, you're not violating anything, we'll all end up at the same place. So with that being said, you know, you can, I've done it by common logs, right? Made it back as one, right? And then done the common log. And then I also rewrote it as a exponential and solved it and still got it as -5, right? Or you could do it as they've done over here by the powers and power properties. Now, which ones will you see? Well, that's dependent upon your knowledge of understanding the properties. Probably, I very seriously doubt you'd go to this property, just because, guys, we didn't do a lot of problems that focused on that. We done problems with expanding, condensing. We looked at that. We did look at solving logs and stuff like that, but you're probably going to go this route to some extent. Your brain will probably go there. So with that being said, pick a route, but just know, I guess when you're looking at a problem, and I want you to kind of think about this. I know we've got 26 hours or 26 and a half hours before we take the final. Not that I'm pressuring you. When you're looking back through the problems, read the problems and think about what it's telling you to do, what information it's giving you, and what approach are you going to take, and then take it, because you've got to understand how to read the problem and how to go it, because the one thing that trips students up is when they read the problem, they don't know what to do. They don't know that first step. And normally, that's when you ask a teacher and they tell you, hey, do this. And then once you make that first step, the ball is rolling, you're good. But you didn't see what first step to take. So that's really what I want you to, you got, I don't know how many problems I gave you to said, hey, make sure that you're solid on these. You need to be able to look at a problem, read it, and be able to sit and think, okay, it's giving me this, so therefore it's telling me this, this, and this, right? You want to be prepared, you do that. You got to work it. You still got to work it, guys. And don't shortcut it. Don't put it on the calculator as far as just doing all the steps. Write it down. You've got to be able to make sure that you have the recall of the kinesthetic of doing the problem, okay? I haven't done 24, I don't think. So I'll do number 24. If that answered everybody's question on that. Angela, did that get you on that?
Yeah, I just didn't, my brain didn't go to 3 to the -1/2 power where I would have seen that property.
Yeah, we just didn't. And the problems that we have on here, the problems in the homework and stuff, they don't emphasize enough of the properties. So therefore, you're not going to be exposed to looking for those properties to make it shorter. That's the kicker. That's the one thing I miss about the other program that we're using compared to this one, because it really went into the properties a little bit more, and you were better prepared. But it is what it is, so we will rock and roll with that. So let me go to 28 real quick. All right. I don't think 28 is 28 one of the ones I circled? I don't think it was. 24. That's why. Thank you. Okay, sweet. Okay, will you see one like this? You probably will. So let's make sure we're on the same page, okay? I would do on this, it's saying write the equation line that passes through 1, 2 and has a slope of 4/5. Okay, guys, they're giving you a point, x and a y, right? And then the slope, right? So there's a form called the point slope form. And I would rock and roll with this all day long, okay? Y minus y1 equals m times x minus x1. So what you have to understand is when you plug these x and y coordinates into the equation, into each one of these parts, you have to change its signs because it's y minus and x minus. So what you got to understand is this 2 now becomes negative 2. The slope is negative 4/5. That's x. This 1 now becomes, it's a positive 1, now it becomes a negative 1. So all we have to do from this standpoint is once we plug those in, it's a simple thing. Distribute and move the negative 2 over to the other side. So that would be negative 4/5 x, and that would be plus 4/5 equals y minus 2, and then we'll go plus 2, right? Now, I'm old school on this, okay? So I'm going to show you how to do fractions, adding fractions, the way that I think about them, old school. You can type 4/5 plus 2 and you'll get, 14/5, which is, 2.8. But you think about this. Let's think about if I take 2 and I rewrite it as a denominator of 5, what would the numerator have to be that when I divide it by 5, I get 2? Well, it'd be 10, right? Because 2 written as 10/5 is the same thing, right? So when I go 4/5 plus 2, I'm really thinking about 10/5. 5 being common denominators. You can't add or subtract fractions unless you have common denominators. So 4 plus 10 is 14/5, or 2.8. And it really depends on, I don't know whether they're going to leave as a fraction or as a decimal, I don't know. But your calculators will handle either one, so you should be okay. But I guarantee you got to be able to do that. You got to be able to take a point and a slope and write the equation, the linear equation from it, okay? You got to be able to take a point and slope and be able to write the exponential, right? You got to be able to do that. That was some homework back in the last little section where I gave you 2 points and said, hey, write the exponential equation for that. I would make sure that I was prepared for that as well. Anything with writing equations, it's a good possibility it's on there because that's content knowledge. You're doing something with some values. So all right. Let me read this. Who's got one here? Dex says 12. So, all right, let's go to 12 real quick. Okay. Let's see what it says for us to do on these. What I'm thinking about it. It says simplify each of the following expressions as much as possible, right? So what we got to make sure that we are doing is we've got to make sure that the radical, or I shouldn't say the radical, the radicand, which are these parts right here, there, is simplified as much as possible. So we've got to figure out, is there any perfect cube that would go into 128? So let's kind of look at this. 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. So, and then of course 1 cubed is 1, right? So let's take 128. So let's get our calculator. 128 divided by 8. Well, it goes into it 16 times, right? So I could say the cube root of 8 times the cube root of 16 plus 3 times the cube root of 2. Well, we know that the cube root of 8 cubed is 2, right? So that's 2. Now, can we look at one of those to see if 8 would go into it? And it does. Or is there a perfect cube, these numbers, that would go into 16? And it does. You know, maybe I should have just chose 64, because 64 is really half of 28, right? So there. So that'd be the cube root of 8 times the cube root of 2, right? So this right here became these. And this became those, right? So you can split something down to become factors of that particular product. So this is 2 times 2 times the cube root of 2, right? We know that 2 times 2 is 4, so we got 4 times the cube root of 2 plus 3 cube roots of 2. Now, what they're trying to get you to understand is, hey guys, if you have the same radicands, I've got the cube root of 2 and the cube root of 2, then you can add their number in front, which would act like a coefficient, right? So that would be 7 cube roots of 2. That's what it would simplify down to. If you have a multi-view, then I think you can type it in the cube root of 128 plus 3 times the cube root of 2 and hit enter, and it should give you 7 times the cube root of 2. It should be able to do that. That's a really good thing about the multi-views and the TI-36X Pro. It will do this right here, except for the variable part of it. It'll do the rest of it. It'll take and do 9 through 14. Now, of course, you'd have to leave off these, right? And then those variables, but it'll do all this right here for you and give you an answer. So, all right. Anything else on that? It's a really good question. You'll see one of those. I mean, you'll see. We dealt with simplifying radicals, whether it was a cube root, square root, fourth root, whatever. But you can kind of look and see how I approached it over here. All right. Anything else, guys? Number 8. Okay. rate. Yeah, these you have to know how to do by hand. So because it's a properties of exponents, one of the ones that we looked at. Yeah, let me cut that and go to a new page. All right. What we're going to have to do is we'll attack this, but I'm going to go ahead and attack this -2 first on this particular problem. And that negative, because these things are raised to a power, raised to another power, this whole parenthesis is being raised to a -2. If you remember, anything raised to a negative power, if it's in the top, it goes to the bottom. If it's in the bottom, it goes to the top. So essentially what you're doing is this to this particular problem. You are flipping the fraction. It's basically the reciprocal. So, and then we have over here, of course, a to the 4th and then 2 squared, right? Now we're just going to say this is 3 times 2 because anything raised to a power raised to another power, you multiply their powers. So this is really a to the 6th over, this is 3 squared, so 2 and 2, this is really 3 to the 4th. Now this is a to the 8th, and this is 2 to the 4th. Let's go this way. Well, I better go down just a little bit more before I go over. All right, so we got to evaluate 3 to the 4th, okay? So 3 raised to the 4th, I think it's 81, so that's really a to the 6th over 81 times a to the 8th over, is that 16? 2 to the 4th is 16, I think. Yeah. Folks, that's going to give us, when we multiply fractions, that's going to give us a to the 14th because when we have like bases, a and a raised to the power, we add them over 81 times 16 is 1296, and that is as much as we can do to that. So any question? Anybody? $29. Okay. All right. This is our mixture, right? And if you remember, we kind of set this up a couple ways in class. Said to do it as a, well, this thing is acting up all of a sudden. Should go to a new one, but it's been difficult. All right, so a chemistry teacher needs to mix a 30% salt solution with a 70% salt solution to make 20 quarts of a 40% salt solution. We done this in a table, if you remember. And let's see, the items, the amounts, solution of totals. So there. Let's see what I've got here. Let's go back. All right. So we have the items. Yeah, you want me to set it up as a system? Doesn't really matter to me. I mean, I can set it up as a system. Why don't I just work it both ways? And that way, you've got the freedom to do it however you want to. Fair enough? I'm assuming the other way you're meaning system of equations, right? Yeah. Okay. So we have the item, we have the amount, we have the percent, and then we have totals, guys. So we have the item that is a 30% solution. We have a 70% solution. And we're trying to make 40%, right? All right, so the 40%, we know we have to have 20, right? This is in quarts, right? 20 quarts, and it's 40%, right? Now, we know that this is a 30 and that's a 70. Those are percent solutions, right? But how much of the 30 and how much of the 70? Well, we're going to say X, and then we're going to say 20 minus X, okay? And when we do that, what it does is when we find X, that'll give me how much the 30% solution, and then I can say 20 minus that, give me the 70. We're going to multiply these together, right? X times 30 is 30X, and then this is 70 times 20 minus X, right? And then this, I think, is 20 times 40, which is 800. So these two added together better equal this, right? Better equal that. So I'm going to set it up. 30X plus 70 times 20 minus X equals 800. And of course, if we distribute, that's 1400 minus 70X equals 800. And then we can combine like terms. That's negative 40X plus 1400 equals 800. And of course, if we do minus 1400, that's negative 40X equals negative 600. And if I use 600 divided by 40, folks, that gives me X as being 15 quarts, right? So 15 quarts in the 30. So 30% is 15 quarts. And then the 70% is 5 quarts for a total of 20 quarts, right? So that's how I would do it if I was going to do it with a table. And I think a table is pretty easy when you sit there and you set it up. So now let's do it again. Let's go to next page and hit paste. Let's do it again, but let's do it with a system. But let me let you look at this right here again. Make sure that you can. Yeah, that's 15. So you got all your stuff in a table. So really the hardest part was saying, oh, we got to fill these in, and once you get these filled in, it's done. It's over with. Because all you have to do is multiply across, set these added together equal to that, boom, done. Okay. But if you want to do this in a system, then you say X is a 30% solution, and I say Y is a 70% solution. Okay. So the first equation I'm going to write is a total, right? This is my total. I have X amount of quarts of the 30 plus Y amount of quarts of the 70 equals 20 cords, right? It's a total. How much do I have, right? Then you're basically values, right? So this would be, I'm going to keep them as without decimals. You can write this as 0.3 and 0.7 and then 0.4, but I'm not going to do that. I'm just going to keep it, 30% times some x, right? Plus 70y is equal to, if you're looking at this is percent times amount, right? That's what these are as well. So what you have to understand is this number over here will be 40 times 20, right? Which is 800. And that because it's percent times amount. So and then of course you just solve the system, right? I'll multiply the top one by negative 30 because I want that to drop, right? Plus, I shouldn't do plus, it'd be negative 30y equals negative 600, right? And then of course this blue and green comes down because I'm not doing anything to it, period. And so it's going to give me this cancel. I'm going to add them together. This cancel out. This is elimination, right? This is 40y equals 200. So y equals what? 5. And that's 5 cords. And that's what we came up with. And then you can plug it back in, the y, the 5 here, right? Equals 20. And you can figure out the x, the 30% is 15, right? So you got it either way. It doesn't really matter. All right. Next question. Are comments about these? So I'm just taking requests, guys. So number 30. All right, anybody else? She's sharing. So all right, we'll work number 30, but if anybody else has got one, we'll share the particular stuff. So, or at least the questions, so you can get yours answered. Okay, yeah, I knew that was going to go right there. So cut this, cut. All right, now let's kind of look at this. If you pay $66 for if you pay $66 for car radio after receiving the discount, what was the price of the radio before the discount, right? So you've got some amount, right, times discount equals final amount, right? So let's kind of look at this. So we don't know what the amount is, right? That's our X, right? But we know that the discount was 75 or 25%, right? Well, it's 25%, but it's really 1 minus 0.25 because the discount is 25%, but the value still there is 75%. So really that leaves me 0.75x equals 66. And if we divide both sides, then we know that it originally cost $88. And we can check that. We can say, hey, $88, you can do it either way you really want, times 0.25, and that would be $22, right? Now I could do 88 minus 22 equals 66, and that checks out. Or I can just say, hey, 88 times 0.75, which is 66. So either way, that's how you do it. But if you'll write it out like this, it'll make a little bit more sense, and it'll give you a little bit more of an opportunity to get this. Now, again, I said amount times the discount, right, equals final amount. You could have done really this should be amount times what's left, right? Really it should be amount times what's left, because that's really what this is, right? 75%. So, okay. Next. Or if you have any questions on that one. All right, anybody? Y'all got another one, or are y'all about math out? We've been going for about an hour and a half now. So, what would you like to do, folks? Let's see who's still here. We still got Hillary. Angela and Al. Dex is still, so we still got a good bit of people still on. All right. If you're good, you can pop off and or hop off, and you can kind of do whatever you want to do. You know, this time's for y'all really, more than anything, to give you an opportunity to ask questions. So that's really what I wanted to do, is give you an opportunity. The ones that you've looked at that you just did not have a clue, or you were like, I wonder what Palmer's take is on that. So Anybody got anything? We got 3 left. Jamaria, Dex, and Al. So I'll take any other ones you got, guys. So just let me know. On. Okay. 103. And let me go here. 103. Yeah, this is good. It's very similar to the quarters, and the quarters thing that we've done, stuff like that. So, oh shoot. Cut. Go here. Okay. Make this. So we're getting into amusement park. So admission into an amusement park for 4 children and 2 adults is $116.90. For 6 children and 3 adults, admission is $175.35. Assuming a different price for children and adults, what is the price of each ticket? Well, all right, this is kind of, so we're going to say X and Y, right? So X is a child ticket, or the cost, right? The cost, and then Y is the adult cost, right? So let's kind of look at this. They tell us that 4 kids plus 2 adults is equal to $116.90. And then they just turn around and give us the same thing, but another scenario, which is another scenario. It's a little bit different than what we have a totals and values, and then this is the other format that they'll ask as far as problems for systems. So what we got to make sure we do from here is to solve it, right? So we're going to multiply both sides, so or both equations. I'm going to make this -6 and this in a +4. Yeah, it's going to make my numbers bigger. I could have got rid of the y's, which would have been smaller numbers, but it's just math, so it's just numbers. So we're not going to be scared about that, having big numbers. Now, I had to make one positive, one negative, so when I add it together, they'll eliminate. So we're solving this system by process of elimination. We shouldn't say the process of elimination, but we're solving it via the elimination process. So so that's -24 minus 12y equals, let me see, 116.90 times 12. No, not times 12, times 6. And it's -701.40. And that's a negative, right? And then, of course, this is 24, and that's x. I left that out. Plus 12x equals, really? They done this to us? Me oh my. 4 and 2, 6 and 3, 6 and 3. No, I'm right. Okay, so equals, all right, 175.35 times 4 is 701.40. If we add that together, that's what we get. That's a bad problem. and I'm curious to see what they done on the thing. They gave us a problem that basically the variables drop, which means it's either a parallel line or the same line. So when variables drop, you compare the left side to the right side on a system, and if they're equal, then it's an infinite amount of solutions, which means it's the same line. But I'm curious to see. I bet you they just picked. Yeah, but let me go back. Okay. Oh shoot. Yeah. Well, it doesn't answer. What's the price of the kid? That they just use numbers that didn't come out to be anything. They should use numbers that actually gave you an X and a Y, so you'd have cost, right? Um, and I don't even know. I mean, they worked this out. They put this as a solution, and then just said that it's and it doesn't. That shouldn't be. They shouldn't have used those numbers. And when they worked out the solution, found that it was an infinite amount of solution, they should have changed it to something that came out with two lines intersecting, which would give you an X and a Y. So that's just laziness there. If you do a key and you know that it's not contextually even accurate, you ought to change the dabbling problem. But it's not my review. I just snagged it from the person. So, okay, I'll quit vending. So, all right, good question there, because if I'd have worked that, I'd have been ticked off, and I'm ticked off that they left it like that, right? Okay. Um, okay, I'll take in one or two more, and I think that'll be about it. That's infinite amount of answers. Yeah, the answer would be that. If you got the green and the purple as a solve the system, then yeah, infinite amount of solutions would be correct if you were just solving algebra. But this is a word problem, and you shouldn't have those type of solutions for a word problem, because you know that the cost has to be some amount, right? You can't just say every X works, and it just does, but you shouldn't. Anyway, they did, and that's nothing to be on ours. Yeah, so they should have fixed the problem. So okay, any more guys? Are y'all good? All right. Well, if y'all good, then we're going to call it an evening. It'll take a little bit for this to convert into an MP4 format, so I can put it up, and then I'll load it up in there. But please make sure you look at those problems that I singled out, and make sure that you can do those. That'd be greatly beneficial for you. And happy studying. Don't stress out. Build your confidence, okay? Thank y'all for attending. We're going to be done.